Welcome to Keentel Engineering. Between now and 2029, NERC is rolling out a wave of new reliability standards covering energy adequacy, cybersecurity, modeling accuracy, inverter-based resource performance, data transparency, and extreme weather planning. This isn't incremental. It's a paradigm shift in how reliability gets defined, assessed, and enforced. Here's what's coming, why it matters, and how 5 real projects already put it into practice. IBRs, energy-constrained generation, cyber threats, and extreme weather are driving this expansion across 5 fronts. Energy adequacy, not just capacity. Cybersecurity for low-impact bulk electric system assets, high-fidelity modeling with ongoing validation, IBR performance and disturbance mitigation, and extreme weather planning instead of just response. Theme 1. The shift from capacity-based to energy-based reliability. Driven by BAL-007-1. Solar and wind variability, fuel supply constraints, and demand volatility are pushing NERC toward energy sufficiency analysis, evaluating energy availability over a 5-day to 6-week window, identifying deficiencies early before real-time operations, and enabling long-lead mitigation like fuel procurement and outage rescheduling. The core question changes from do we have enough megawatts to do we have enough megawatt hours over time? Theme 2. Cybersecurity expansion to low-impact systems under CIP-003-9, CIP-012-2, and CIP-015-1. About 66% of low-impact bulk electric system cyber systems have external connectivity, a major and growing attack surface. CIP-003-9 focuses on vendor remote access, supply chain vulnerabilities, and malicious communications detection with new requirements to detect inbound and outbound malicious traffic, monitor vendor remote access sessions, and disable vendor access when necessary. Theme 3. Modeling accuracy and validation under MOD-026-2, MOD-032-2, and MOD-033-3. With rising IBR penetration, system behavior is more complex and less predictable. So these standards require accurate dynamic models, comprehensive data reporting, and ongoing validation, with the intent that models truly represent real-world equipment, IBR controls, HVDC systems, and dynamic reactive devices. Theme 4. Inverter-based resource enforcement, now the central reliability concern. PRC-029-1 requires ride-through. IBRs must stay connected during disturbances to prevent widespread tripping. PRC-030-1 covers event mitigation, identifying and mitigating unexpected power output changes like solar tripping. And PRC-024-4 covers protection alignment, matching generator protection settings to system needs. This is a direct response to California solar disturbances and IBR performance issues in WECC and ERCOT. Themes 5 and 6. Data transparency and extreme weather. TOP-003 and IRO-010. 6. Expand data requirements for balancing authorities, transmission operators, and reliability coordinators. BAL-007-1 explicitly links to TOP-003, so balancing authorities must define data specs and other entities must provide it. And TPL-008-1 makes extreme weather planning a requirement, not just an operational concern, mandating planning for extreme heat and cold, reflecting Winter Storm Uri, western heat waves, and fuel supply failures. 6 grid risk areas, each tied to a standard family. Energy shortages to BAL-007-1, cyber threats to the CIP standards, modeling inaccuracies to MOD-026 and MOD-033, IBR instability to PRC-029 and PRC-030, data gaps to TOP-003 and IRO-010, and extreme weather to TPL-008-1. The result, a transition toward a data-driven, predictive, and resilient grid. Case Study 1, BAL-007-1 as Southwest Balancing Authority. The challenge, 45% solar and wind penetration with heavy just-in-time gas dependence and limited storage. Summer forecasts showed a possible 3 to 5 day energy shortfall traditional planning would have missed. Keentel built a 14-day rolling ERA model, modeling fuel depletion, renewable intermittency, transmission constraints, and interchange limits. Then built operating plans for gas pre-scheduling, battery dispatch, and demand response, integrated into day-ahead planning and real-time dashboards. The result? A 1,200 megawatt-hour deficiency risk identified 4 days in advance and emergency load shedding avoided. Case Study 2, CIP-003-9, a Midwest utility. The challenge: 200-plus low-impact systems with extensive VPN-based vendor access and almost no session monitoring. Keentel's risk assessment found unmonitored access, shared credentials, and no session tracking. Then redesigned the architecture with jump servers, multi-factor authentication, and role-based access control, plus intrusion detection and SIEM integration. The result: full visibility of vendor sessions, an 85% reduction in unauthorized access risk, and a past audit with 0 findings. Case Study 3, IBR Ride-Through, a solar and storage developer in ERCOT. The challenge: a 300 megawatt solar plant partially tripped during a disturbance, traced to overly sensitive inverter protection and non-compliant ride-through. Keentel ran electromagnetic transient simulations and fault replay modeling, validated inverter control logic against PRC-024 curves, then adjusted the ride-through curves and frequency thresholds, and resubmitted updated models to the ISO. The result: full PRC-02-9-1 compliance, nuisance tripping eliminated, and improved grid stability contribution. Case Study 4, CIP-012-2, a transmission operator. The challenge: multiple control centers exchanging real-time SCADA and EMS data over unencrypted legacy links with no redundancy. Keentel mapped every link and protocol, then implemented end-to-end encryption, redundant paths, and failover mechanisms with a multi-entity responsibility matrix. The result: secure, redundant communications, reduced cyber exposure, and improved system resilience. Case Study 5, TPL-008-1, a Texas utility. The challenge: after a winter storm, generation outages from fuel freezing and equipment failure, with load surging beyond forecast. Keentel built extreme cold and fuel disruption scenarios, ran load flow, contingency analysis, and generation derating simulations to find critical failure points, then built mitigation plans, a fuel diversification strategy, and load shedding prioritization. The result: reduced cascading outage risk, improved winter readiness, and stronger regulatory compliance. What is BAL-007-1 and why does it matter? It introduces energy reliability assessments to evaluate energy sufficiency over time, catching risks traditional capacity planning misses. What is an energy reliability assessment? An evaluation of whether enough energy, not just capacity, is available over 5 days to 6 weeks. How does BAL-007-1 differ from TOP-002? TOP-002 focuses on day ahead. BAL-007-1 extends to weeks, enabling earlier mitigation. Why are energy-constrained resources a concern? Fuel limitations and variability can cause shortages even when capacity looks sufficient. What industries are most impacted? Balancing authorities, ISOs and RTOs, large utilities, and renewable-heavy regions. What's the biggest change in CIP-003-9? It expands cybersecurity controls to low-impact bulk electric system assets, especially vendor access. Why is vendor remote access a major risk? It introduces supply chain vulnerabilities and external attack vectors. What new cybersecurity capabilities are required? Traffic monitoring, access tracking, and remote access disabling. What is CIP-015-1 focused on? Internal network monitoring to detect anomalous or malicious activity. What does MOD-026-2 require? Verification that dynamic models accurately represent real equipment. Why is model validation critical now? IBRs introduce nonlinear, fast response behavior that has to be accurately modeled. What is MOD-033-3? A standard requiring continuous validation of system models. What is PRC-029-1? A ride-through requirement ensuring IBRs stay online during disturbances. Why are IBRs causing reliability issues? They can trip unexpectedly from control settings or protection misalignment. What is PRC-030-1, a standard to mitigate unexpected IBR output changes? What's the purpose of PRC-024-4? Ensuring generator protection doesn't cause unnecessary tripping. How does TOP-003 support BAL-007? It ensures the data needed for energy reliability assessments is available. What is IRO-010-6? It defines data requirements for reliability coordinators. What is TPL-008-1? A planning standard for extreme temperature events. Why is extreme weather now a planning requirement? Recent events have shown weather-driven failures can collapse systems. What tools are required for compliance? PSSE and TSAT, PSCAD, Power Factory, and EMS and SCADA analytics. How do these standards impact renewable projects? They significantly raise modeling, compliance, and performance requirements. What's the biggest compliance challenge? Integrating modeling, operations, and cybersecurity across organizations. When do these standards become enforceable? Between 2026 and 2029, depending on the standard. How should companies prepare now? Conduct gap assessments, upgrade modeling capabilities, improve cybersecurity posture, and develop ERA processes. Between 2026 and 2029, NERC is rolling out the biggest reliability overhaul in decades. BAL-007 shifts planning from megawatts to megawatt hours. CIP-003-9 brings cybersecurity to low-impact systems, most with unmonitored vendor access. New MOD standards demand model validation. IBRs now face strict ride-through enforcement after California's solar trip events, and TPL-008 mandates planning for extreme heat and cold post-URI. At Keentel Engineering, we help utilities and developers get ahead of all 6 standard families. Now, not in 2029. For more information, visit keentelengineering.com.